Right. Want to look at sets and Venn diagrams. Right. Want to use a question to explain Venn diagrams. So I think I told you last time the symbol which I used in the set theory. We said a rectangle represents a universal set, where we said a universal set is the mother set from which other sets can be obtained or derived. Are we together? So in this case, the question reads, given that a universal set, that the symbol for the universal set, this is the universal set, is equal to a set such that, or which contains x, such that x is less than or equal to 0. So the 0 is less than or equal to x, and the same x is less than or equal to 10, where x is an element of integers. So this is the universal set, the mother set from which other sets can be obtained or derived. Then from the mother set, I said last lesson, we have what are called subsets. And I say the subsets are smaller sets which are obtained from the mother set, which is our universal set. Then universal set are represented by circles in mathematics, while the universal set is represented by a rectangle. Then subsets are shown by circles. A subset is the smaller circle obtained from the universal set. A universal set is the mother set which is used to make other smaller circles, and the universal set is shown by a rectangle. Then a subset is shown by a circle, and normally we use capital letters or upper cases to represent subsets A, B, C, or D, but there will be capital letters. So in this case, we have three subsets. We have subset A, subset B, subset C. Subset A is a set of prime numbers. Subset B is contains 2, 4, 5, 9, and 10. Subset C contains 1, 4, and 9. So this is I've shown you the universal set and the subsets. Super subset is a set which is found inside another set. Is it fine? A super subset is a set which is found in another set. Are we fine, guys? A super subset is a set which is found in another set. We're going to look at super subset sometime later. I'm just summarizing what we did last time. So this is our question now. We want to represent. The person here said represent these sets on a Venn diagram. This is our question. 3 marks. This is a ZIMSEC question. So, chokutanga nditi, first and foremost, solution. Our universal set is not clear. So if the range is small, it is wiser to list them up. So in this case, the universal set contains x, such that x is between 0 and 10 inclusively. So we have 0, we have 1, we have 2, we have 3, we have 4, we have 5, 6, 7, 8, 9, and 10. So that is our universal set. Then set A is already given. It's 2, 4, 5, 9, and 10. Then set B contains, so this set B already, sorry, this set B already, set B. Then set C is given as 1, 4, and 9. Then set A is set of prime numbers. So this question now, prime numbers, what are they? What is a prime number? A prime number is a number which contains only two factors. So which has two factors only, which are 1 and itself. Inamba isingadivide nzimwe number kuze kungoti iyo inongodivide na 1 oro na itself. Haina zvimwe zvinopinda mairi prime number, inongopindwa na 1 kana kuti iye kuzvidivida. It has only two factors which are 1 and itself. So from our mother set, what are the prime numbers? Which numbers have only two factors? So we have 2, yes, correct. We also have 3. We also have 5. We also have 7. Those are the only prime numbers from our universal set. Now from these, from set A, set B, set C in the universal set, now want to come out with a Venn diagram. So what we first do is we draw a universal set. Yes, we label like this. Then you analyze your subsets. There are 3 subsets here. You compare subset A and subset B. Are they intersecting? Yesterday we looked at the intersection of a set. Are they common elements between A and B? Yes, A contains A, B contains A contains 2, B contains 2. A contains 5, B contains 5. So it means somewhere A and B, they are intersecting. So this set A, this set B. What about C and B? C and B. C and B. C and B. There's 4 here. There's 9. Okay? Because C and B, they are intersecting. What about 2 and what? What about C and A? C and A, there's nothing in common. Which means A and B, they're intersecting. Yes. Then B and C. B and C, they are also intersecting here. A and C, they don't intersect at all. Can you see? Analyze the 3 sets. You look between A and B. Are there something common? Then you overlap them. But this space means there are some common elements between A and B. Then you look at what A and C. Is there anything common? 1, there's no 1 here. 4, there's no 4 here. 9, there's no 9 here. It means A and C are disjointed. I think I told you about disjointed sets. They are disjointed. So which means now, these are the 3 sets now. So what is found in A and B? A and B, we have 2. A and B, 2. We have 5. That's the only thing which I have, A and B. Then between B and C, we have 4. We also have 9. Then what is found in A only? What is in A but not in B and C? So muna A muna 3. We have 3 here. We have 7. What is in B but not in A and C? Tina 10 only here. We have 10 here. What is in C which is not in B and A? See, there's nothing. We only have 1. Can you see? We only have 1. So then what is not in A, B, and C? So we put in the universal set here. So check your diagram. 0 is not in all these. 0, 1, 2, 3, 4, 5, 6, 7, 8. 8, yes, so there. 9, 10 is already there. So that is our universal set. Is it clear, guys? So chakutanga, and let me speak in Shona. Chakutanga ukapokuseni yakanditi yakati says if the range is small, try to list them down. But if the range is too big, for example, 0 to 50, you cannot list all those elements from 0 to 50. Then ukapuwa prime numbers. Chakutanga ziva kuti what is a prime number? Wona kuti which prime numbers are there in this from the universal set? What are the prime numbers available? Woma list. Then set B is already given, it's fine. Even set C is already given, it's fine. Then when you want to make out a universal set now, first of all, identify common elements in any given sets. Could kunema elements are intersect here? You check A and B. You check B and C. You check A and C. So if like in this case now, if you look at set A and set B, 2 is in both A and B, and 5, they are common. We put them in this region, in the area of overlap. Area ya overlap, okay? The my elements are A and B. Again, we check out A and C. Is there anything common? Can a passing night means A and C are overlap? But look here now, Tina B na C, and B na C, do they share something common? B na C nani in a 4 and in a 9 rakari. So 4 and 9 they are found in both B and C. We brought them here. But they belong both to C and also to B. What is that? What cheka zasirimuna A, B, C or zuruma intersecting regions. Wozvina kunze kwechi kuma subsets ako. Unenge wakombia zvawanyora panditi nezviri universal set. The elements which are not yet included. Let's go. Right. There's a question, guys. Second question, which I want to explain clearly. That is our question. Given that the universal set contains x, such that x is between 0 and 15 inclusively, where x is an integer. I was supposed to write this condition inside the universal set. Is it fine? Right. Then A is a set of prime numbers, which means all prime numbers which are inside the universal set is called, and they fall under set A, subset A. Then all odd numbers that are in our universal set, we label them, we put them under set B. Then 1, 2, 5, 6, 11, 12, 13 are the members of set C. The question says represent these numbers on a universal set. So it is wiser, but from 0 we cannot write down 0 to 15. The range is too big. We just ignore. We can try to list down solution here. We try to let us list down the elements of A. What are the elements of A? Prime numbers between 0 and 15. We have 2, we have 5, we have 7. I left 3. Let me put it here. Don't worry about the order. We have 2, 3, 5, 7, 11, 13. These are the prime numbers which are in our universal set. And I said the prime numbers are those numbers which only have two factors, which are 1 and itself. They are not divisible by any number except by 1 and by itself. Then set B is a set of odd numbers. What are odd numbers? These are numbers which are divisible, which leaves a remainder of 1 when divided by 2. So whenever you divide them by 2, they leave a remainder of 1. Those numbers are called odd numbers. So in our case here, from the universal set, what are the odd numbers here? We have 1, we have 3, we have 5, we have 7, we have 9, we have 11, we have 13, we have 15. So these are the odd numbers. Then set C is already given as 1, 2, 5, 6, 11, 12, 13. This is set C. Now we look at these 3 sets now in the universal set. We now draw a Venn diagram now. First of all, we draw the mother set, the universal set like this. Then check, are they elements which are found in the 3 sets? 2 in the 3 sets, 5, 5, 5. And then we have 11, 11, 11. It means the 3 sets intersect somewhere. So we make sure that the 3 sets, they all intersect. So this set A, set B, set C. So if there are some elements which are found in A, B, and C, it means the 3 sets are all intersecting. Arosangana ose. Then chokutanga before nambira. First and for all, identify the elements which are found in all the 3 sets. Mark them. So we have 5 here, 5 here, 5 here. You record it at the central region here. It's 5. So we have 7, 7, no. 3, 3. Here, no. 11, 11, 11. Yes, we also have 11 here. You check nicely. 13, 13, 13. It is also there. So these are the 3 elements which are found in the 3 sets. Right. Now, you look at the elements now which are now found in set A and B only. Set A and B. So which set A and B only. The remaining ones, 2, no. You are checking here. 2, no here. 5 done already. 3, we have 3, 3 here. So write 3, 3. 3. We also have 3 is done. We have 7, 7 here. Can you see? 7, 7. I put 7 here. 7, 7. Yes. So you mark it out. Then you now look now. Are there any elements which are found in A, set A and C, which we write here? Only A and C. A and C. So what is found in A and C? 2 is in both. Yes, 2 is in both. A and C. 2 is here. 2 is here. We mark it out. Then what is also found in A and C? That's the only thing. Never ever repeat an element. Never ever leave out an element. Right. Then what is found in B and C? B and C. 1, 1. 1, 1 is there. I record it here. Mark it out. 9, no. 12, no. 10 is already recorded there. So that is only number which is found in both in B and C. So now what is in A only? Now look at A now. All elements in A have been listed out. So it means there's nothing you are going to write in this space. What is found in B only, which is not in A and C? B, the remaining elements in B, the 9 is not recorded yet. So it is this is what B only. Or marker. Then we also have 15 here. It has not been recorded here. Write it here. Is it fine? Then we have anani. Muna C. Which elements are found in C, which are not also, which has not been included here? So we have 1 is 2, the 5 done, 6 is not yet. So write 6 here, not yet. We also have 12, not yet. You see now. So if you look here, now you have put all the elements in A, B, C. They have been listed down. Yes, they all have been listed down. Right. So after listing this up now, we now go to our universal set now. What is now remaining amiss? what has not been included so far. So we have 0, 1 is there, 2, 3, 4. 4 is not being included so far. 4, 5, 6, 7, 8. 8 not yet. Record it. 9, 10, 11, 12, 13, 14. So these all the remaining elements now from the universal set now, we write them outside our 3 subsets. So this is how we represent information on a Venn diagram. So there are 3 main cases. So this is the first case whereby 2 sets, there will be 3 sets. 2 sets, they are disjointed, they don't intersect, like A and C. Then the other 2 intersect. Pane mbili zingasangani and completely. So we come out with a setup like this. Then pane case yokuti all the 3 sets, they intersect somewhere. Then let's move on to the last case. Right, that's the person, guys, which I have designed now. So our universal set is from 0 to 10. Is it clear? Then set A contains 2, 4, 9, and 10. Set B contains 1, 3, 5, 7, 9, and 10. Set C contains 5 and 7. The question says represent this information on a Venn diagram. Solution. So first of all, study, is there found in A, B, and C? A, 2, 4, 9, 10. So in A and B we have 9 and 10. Then A and C, there's nothing common. But A and B, 5 is in B, 6, 7 in B. 5 is inside set C. All elements in C are inside B. Can you see? Which means C is a super subset of B. C is inside B. Is it fine? So now we are going to have situation like this. Our universal set. Then now A and C don't intersect because no elements in A and C are common. So we only have A and B. So A and B, they are overlapping. This is A, this is B. So what is found in A and B? First of all, write down common elements which are found in both sets. So we have A and B. We have can you see? Can you check? A and B. We have 9. We have 10. Is it fine? Then we come to B and C. All elements in C are in B. Which means set C is inside what? Is inside. Set C is inside set B. So which means 5 and 7. So which element in B if remained out? We have 1. We have 3. Yes. 9 and 10, 7, 9, 10 are already included. Then we come to A. Which elements are not included so far? We have 2. We have 4. Right. Now, you see now, set C is inside set B. Now we look at which elements are neither in these 3 sets. Are not in set A, set B, and set C. We compare these elements now. We will now compare these elements with the universal set. 0 is neither. 1, 2, you should such 1, 2, 3, 4, 5, 6 is not there, right here. 7 is there. 8, is not here, 9 and 10. So this is now our universal set. So these are the three main cases of major ones, whereby the three sets overlap. In this case, the three sets overlap like this. Then whereby only one of the two sets, they don't intersect at all. We come out with a linear relationship between the three sets. Then we have this one whereby the three sets intersect at one point. Then lastly, whereby one of the sets, third set, is inside another set. And at the same time, this set C now and set A, they are also disjointed. There's nothing in common here. Together we. So guys, this is our set representation of information on a Venn diagram. There are so many examples. We can use triangles. We can use triangles. We can use many features to present or represent information on a Venn diagram. I've just given you whereby I use the concept of numbers to represent information on a Venn diagram. But we can also use things like odd triangles, This is our universal set. For example, we have this is our I want to see, right? So we set A is a set of what? Isosceles. Is it fine? Set B is scalene. Set C, right angle triangle. You see now. So these are just an example for your enrichment. So isosceles triangles, you have two equal sides. Scalene triangle, you have three different sides. Right angle triangle, you have one right angle. But do you know that isosceles triangles can be scalene? Sorry, isosceles triangles can be right angled. Scalene triangles can also be right angled. But no isosceles triangle can be scalene, because right angle triangles have two equal sides, while scalene triangle you have three different sides. Or you can say isosceles triangle you have two equal angles, which we call base angles. Scalene triangles you have three different angles, which means set A and set B, they will never intersect. Is it fine? So set A and set what? Set A and set C, they are disjointed like this. But between A and C, then B and C. So it means now B can be, C can be scalene. Because some right angle triangles, they can be scalene. Some right angle triangles can be isosceles, like this. In this case, this is a scalene right angle triangle. This is a isosceles right angle triangle. In this case, this is a right angle triangle, but the thesis now, all the theses are different. This is, for example, this is 2, this is 3, this is, just an example, 5. And this is, for example, 4, this is 4. And this is something else. But they are both right angle triangles. But one of them is scalene, one of them is what? Isosceles. So which means set B now. Set B can be this set A and this set B, sorry, set A and B, they will never intersect here. Set A and B, they will never intersect, because no isosceles triangle can be a scalene. But set C now can be found in both like this. This is our set what? Our set C. It's now. It means say some isosceles can be right angled. some right angled can be scalene. So this one is very similar to this one. It is very similar to the first case. These are very similar. Where these are triangles, these are numbers, but they have the same analogy. Thank you very much, guys. Thank you. Meet you again in our next lesson, whereby we are going to look at the steady bit notation. Thank you.